Hi everyone, my name is Matt Krajanowicz. I'm a software development engineer at Microsoft. I work on the Windows Server side. Specifically, I worked on the remote shared virtual disk protocol and the surrounding products around it. In the room, we also have some other folks from our product group. We've got Balaji Sikar here, who is our product group tester, Jose, who is one of our PMs, Patrick's a PM, and other associated folks who you all know. Yeah, I gave a talk last year. There's going to be some repeated information. Some of it's not. I tweaked it. So we'll go from there. First, what I'm going to talk about. I'm going to talk about why this protocol exists, our product reasoning behind it, why we wanted to do it, why we did it, and how it fits in. I'll give you guys an overview of the protocol and some implementation notes, sort of an overview of what key points, what you need to do to implement the protocol. And then I'll talk about, okay, so you decided you do want to do a protocol implementation, some of the troubleshooting tools that we have already in the product. I'm not going to go into our protocol test suites or anything like that. I believe that'll come afterwards, and I'm not the right guy to talk about that anyways. So first off, why MSRSVD? The first thing you'll notice is I switched terminology here, and I went from MSRSVD to shared VHDX files. In the product, we call this shared VHDX. And what that means is it's a way to share virtual hard disk files among different guest virtual machines. So one hard disk file shared to multiple guests. So the question we asked was, how could we provide a better high availability story for virtualized workloads? Okay. Before this technology, the only way that you could provide this type of story was to do either iSCSI in the guest, virtual fiber channel in the guest to enable guest level application failover, or you could make the VM itself highly available and do host level failover. Okay? So we realized virtualization's everywhere. It's going, that's where we're going from there. We do want high availability, okay? And high availability in the host isn't good enough. And what I mean by that is, if you make your hosts have highly available VMs, the unit of failover is the virtual machine. So if there's some kind of problem or failure, your application hosting environment, your virtual machine, essentially has to crash and restart. Okay, that's unclean, that can be slow, depending on the workload inside there. You might have to do log recovery or something like that, and that's a really ungraceful way of failing over. So we do want to push as much as we can up into the guest. Okay? In the guest, Windows Server failover clustering, you do need shared storage. Okay, so we have iSCSI. You can definitely do iSCSI. Or you can do virtual fiber channel, and those are both great technologies, but they do require having some infrastructure leakage. Either your infrastructure fiber channel network needs to be up in the guest, or your infrastructure iSCSI network needs to be up in the guest. And if we want to isolate these two things, then iSCSI and virtual fiber channel aren't really the best option. Okay? The best option is to have just a SAS disk inside the guest that's provided, and you've completely removed, completely separated, completely virtualized the hosting infrastructure from your tenant. Okay? So that SAS, that shared disk, is what shared VHDX is and why we have a new protocol. Okay? So from the guest perspective, it looks just like a normal disk. Okay? In this environment, it looks just like a normal disk. It shows up as a SAS disk. You can do any SAS disk things you want to do on it. It's a SCSI device. From the host perspective, it's just a bunch of files. Okay? The fact that it's a bunch of files makes management really simple. Right? You can drag and drop files just like you're used to. You can do normal virtual hard disk file management just like you're used to. All the same administrative actions and verbs and technologies and techniques still apply. Okay? So from the guest, cool, I've got a disk. From the host, cool, I've got a file. It really simplifies the administration and so on. All right.
When you say that high availability on the host is not enough, why is that? I mean, if the VMs could fail over on the host, it's still highly available. Right? The application need not necessarily see a glitch.
Absolutely. So the question is, why is high availability in the host not good enough? And the answer is, if you have high availability in the host, then a virtual machine failure is like pulling the power cord on a virtual machine. So any application running inside that virtual machine has to restart when you restart the virtual machine on another host. So you have to boot the operating system, and you have to start the application. Does that answer your question? Okay. So if you have it inside the guest, you don't have, there's no reboot, there's not necessarily a log replay depending on how it happens. It's just a more graceful thing. Okay? All right. From the administrator's perspective, again, they're just files. If you want to add them to a virtual hard disk, this is on your host or something managing the host. You create a VHD file on a file server, just like we're used to. You add the VM hard disk drive to the virtual machine. You specify an additional flag that says, hey, you want to share this. Right, but that's the only difference. Share it, don't share it. That's how you set up your host. It looks just like any other virtual hard disk. Here, this virtual machine has an IDE drive that it's the boot drive and 2 of the shared drives. Right? But again, all the same PowerShell commands work. It's the same management methodology, and so on. Okay, now, RSVD, Remote Shared Virtual Disk Protocol. How it enables it is between your hosts. The gray boxes at the top are hosts. They've got virtual machine workloads running. And your file server, right, there's SMB. Right? That's a protocol we have. Supports RDMA. We've got great failover semantics, all those things. And we wanted to capitalize on top of that and also add block semantics. So SMB is a transport. It's running general file semantics, file reads, file writes. On top of that, using that transport is the Remote Shared Virtual Disk Protocol that lets you do your block semantics, your SCSI commands, persistent reservation commands, and so on. We have a question? Yes. Yeah, from a protocol perspective, you can use any file as a block device. Yeah, so the question was only inside the VM as a block device. So using a Windows Server client here, that will get pushed up to the VM. If you had an RSVD client, a third-party implementation, the protocol is just block devices or block commands over SMB. So that's there. When I talk about things, I'm going to focus on the case where you've got a Windows client and a third-party file server, but you could definitely do the opposite. That totally works as well. Okay? So we have our file server. It's got files, it's got SMB, and it's got the Remote Shared Virtual Disk Protocol. Okay? This also answers the question about why you need a new file server or new technology on the file server to enable this. The actual understanding of the virtual hard disk file of these block commands is put on the file server. Okay? So in a traditional VM workload, without this sharing, then the hosts are the ones that do all the file parsing. Right? A SCSI command comes down, and then the host will send reads and writes as appropriate across the wire to figure out what data it needs to, but it does the SCSI translation. Okay? With Remote Shared Virtual Disk, RSVD, we're pushing that. Right? RSVD transports block commands, and it's up to the file server to support those block commands. Okay. All right. So what is it? We talked about it a little bit. It's a SCSI transport over SMB. It's full SCSI. It's just a transport, any SCSI commands you want. And we talk about block semantics transported over a file protocol. Okay. So now I'm going to switch gears a little bit, and I'm going to talk a little bit about the protocol itself. All right. Here's how, let's say you've got a file server, and you want to support this, some of the points that you might want to know. And through that, I'll also talk about some of the key points of the protocol. Any questions? Any other questions before I go on? No? Perfect. Okay. All right. First thing I'm going to talk about is how you report that you support the protocol. Okay? This isn't tied to an SMB dialect. It isn't tied to a versioning, like a server operating system versioning story. There's a new file system control that talks about, the client says, hey, what kind of remote shared virtual disk do you support? Okay? There's 2 4-byte flags that are part of it. The first one says, hey, do you support it or not? Right now, you enable the flag. It says supported, yes. Okay. The second one is a handle state. And this allows administrative clients to have a better experience when dealing with it. Remember how I said that the parsing changes, right? In a traditional world, the file parsing happens on the host. And in this world, the file parsing would happen on the file server. Well, in this case, because it's happening on the file server, traditional file semantics might return sharing violation, for example, or you can't access the file because it's locked by the parsing engine that's on the file server. Well, in this case, you can query the handle state and know from a client perspective, like, hey, is this file open in shared mode by anyone? Okay, if it is, then I need to make sure I access it through the remote shared virtual disk protocol. Okay. Is it open in this mode by me? Okay. Or is it not open in shared mode at all? And if it's not open in shared mode, file is not open, you're free game to use any normal sharing semantics that you'd want to use. Okay. So you've done that. You've reported that you support it, which is great. You move on. Okay, so let's talk about what happens when you create a file. Okay, so I'm going to open a file in shared mode. Okay. It's a create file request. It's a normal SMB2 create file request with a couple slight key things. First is there's always a specific alternate data stream that's added to the file. Okay, the alternate data stream is called shared virtual disk. Okay, that's the key. If that exists, then you want to open it up in block mode. And there are some nuances there that I'll talk about. Okay, but shared virtual disk, open it up in block mode. As part of the create, there are some extra create parameters. It's just a block device extra create parameter that goes with it. It's going to come either one or two modes talking about how the file is opened, and then it's always going to be non-buffered I/O. Okay. So you open a file like this, it's a block device. Okay. Diving into that context, it's got some information about the client version. I'll go into the versioning story later. An initiator ID. So for SCSI commands, having an initiator ID is useful. It's a GUID. However, it's not necessarily included. It might be all zeros. So for administrative operations, it's not tied to a virtual machine, and so the ID will be 0. Yes, we have a question? The question is if it's a hint, or I didn't catch the rest of that. Or if there's anything stored in the stream. There's no information stored in the stream. It's a hint. It's a decorator. Okay. So initiator ID. It's a GUID, 128-byte GUID. Okay. The host name, again, optional. This is the host that the virtual machine resides on. It makes it really useful for debugging. If on the file server you can say, hey, this VM ID on this host is causing a problem or having a problem. Gives the administrator a good place to look. Some flags describing the open, some flags describing where the open came from, and a request ID. And again, request ID, it's just like a sort of an activity ID. It's a debugging tip. Okay. Any questions about that? Okay. All right. So you've got your session established. Go for it. This is on the request, correct? Nothing interesting on the response. Okay. So you've got a block device open. SCSI commands can be flowing. There are some other associated meta operations that you can do. Right? You can retrieve basic information about the file server version and about the file. So that includes the length of the file on the underlying object store. So if it's a dynamic disk, how much it's actually taking. You can get the server protocol version and so on. Okay. Some geometry information about the device. So block size, how big the virtual device should be. So again, using the dynamic example, you could have a 64 terabyte virtual device that's only using 5 gigabytes of space on the underlying storage. Some connection status requests as part of the health checking on the client. Periodically, these connection status requests are sent, saying, hey, are you there? Are you good? Happens periodically. And then also a request to validate the virtual device. So validating the virtual device, it's an administrative thing. So if you run the PowerShell commandlet to say test the virtual hard disk file, this will get passed through, and you can use that as a way to say, hey, is the vial corrupted? Is there any data corruption that's going on, or is there anything invalid there? Any questions about this? Yeah. It's really up to the file server, and depending on how it does it. So for example, there might be, again using dynamic disks, a pointer to different valid sections of the file. And that might, let's say, get corrupted for some reason. Maybe your underlying storage has problems or something like that. It's an administrative operation. I don't really know how common it is to be in practice, but it's there and the capability is there. And the question is what does validate do? Okay. Any other questions? Awesome. I'm clicking right along here. All right.
So it seems like some of those overlap equivalent operations that you issue against that file without the MSC, right? You can ask just a sparse file.
Absolutely. Okay. So yeah, I was about to get there. The question is, some of these overlap with general other queries. Like you can ask if it's a sparse file and things like that. In that case, it depends on if the file actually is marked as a sparse file, right? If it's not marked as it doesn't have to be a sparse file to be a dynamic virtual disk, for example. So.
I guess what I'm saying is that, for example, you can retrieve, you gave the example of takes up 4 gig on disk, but it's really a 64 gig file.
Mm-hmm.
You can also query allocated blocks. You can query info, right?
Yeah, absolutely. Although in the query info, that's actually virtualized. So in this case, and I don't talk about that here, that's a good catch, the query info will return the total virtual device length.
Oh, so query info.
So if it's a 64 terabyte file, it'll return 64 terabytes EOF, end of file.
No, I agree.
Yeah.
You can also query the allocated blocks, right?
I think so. I have to double check what we do there. Honestly, I don't remember. You're right. I mean, there are going to be some ways that you can find this information by not going through these things as well. Yeah. However, if we were to zoom in on the details of this, and I don't have a nice graphic for that, it's a very limited subset, I think. Most of it is things like, the virtual block size and the file server version, and some of it is simple, like, okay, how big is the file on the disk? But I'd say that's probably the subset of information. And it's just more convenient to get it through these things in the way that we would expect to see it on the client than it is to do it out of band. That's a good question there. Any other questions? Brilliant. So moving along. Okay, so I talked about all these meta operations. Let's talk about the SCSI commands themselves. Okay, SCSI commands are tunneled the same way as meta operations. And by that, there's one file system control that all of these commands go through. It reminds me of that movie, I Have One Question and 27 Subparts. So this is here. It's one file system control, many different sub-operations, and the sub-operations are all versioned and all that jazz. One of those operations is, hey, here's a SCSI command. Okay? It's any SCSI command. It's just a transport. From a protocol perspective, it's totally just a transport. Any CDB, any data you want to pass with it, good to go. However, there was some SRB terminology leakage, and sorry. Okay, it's not necessarily relevant. Some of those cases, there's duplicate information. Sorry about that. SRB stands for SCSI request block. It's the internal data structure name used in the Windows like SCSI stack. It's what a mini port driver on Windows would have to implement and deal with. Didn't really need it, but it's there. So, sorry. Okay. So SCSI commands, general case, everything is good to go. Persistent reserve in, good to go. Persistent reserve out, good to go. Even SCSI read and SCSI write if you want, that works. However, there are some limits. So the file system control is limited to 64 kilobytes. So if it's a read or write, then it's a megabyte read. There's some problems there. And there are some advantages to using file read and file write for performance reasons as well. And so we want to capitalize on that. We want to make it as fast as possible. So reads and writes are special. We issue generic SCSI read, SCSI write. So an ERP read, ERP write. through there. And it returns success or a special error code. And the reads and the writes are all at these virtual block offsets. Right? So it's a block device, 64 terabyte disk. Right? You're reading 512 bytes at logical block address 0. Right? That translates to a read of 512 bytes for offset 0 instead of one block at offset 0 and so on. So it just translates.
We do not get to channel all the SCSI read and write for the SCSI.
So say that again one more time.
So there's a whole subset of the SCSI standard that's involved in read and write, obviously.
Yeah. Okay. So the question is, there's a whole subset of the SCSI.
That standard, they're basically saying you don't push that part of the standard across the earth.
Okay. So the question is, there's a whole part of the SCSI standard that's blocked, that's allocated to reads and writes, and we just sort of ignore that. And for the most part, that's true. Okay. For the most part, in the sense that we see a read, we translate it to a SCSI read, and then or to a file read, and then in the file server, it gets translated back to a SCSI read. Okay. And so it's just the actual read or write command that gets translated from block offsets and block lengths to byte offsets and byte lengths and gets sent over, and then it's re-translated back in.
Just, okay.
Does that make sense?
Aspects of it that we are enforcing a lot that is still being done on the back end side.
Right, and so Vinod, who's my boss, said that what happened here is all the SCSI enforcement still happens on the back end, and that's true. If you have a persistent reservation or the read or write's invalid for some reason, that all happens on the back end.
We'll get off of error code back via the read and write.
Correct. It'll get bounced via error codes back via the read or the write. Depending on the error code, there's a mechanism of how that happens, and that's what I'm going to talk about right now. So, okay, so reads and writes, and this is in this sequence diagram, I chose a specific error code back, so status svhdx error stored. So the error has been stored on the file server. Okay. So file IO has status codes, one NT status code, right? Whole long list. Block IO has sense data. It's got a SCSI sense key, additional sense key, the SCSI status code, additional sense qualifier, and it's extensible. There might even be more information there. From the protocol perspective, we're saying, okay, that definitely exists. However, the common case is that reads and writes succeed. We're assuming that's the common case. People are reading and writing. Data path is going to be the most exercised. Cluster membership and the guest isn't going to change that often, so we're not going to see too many persistent reservation failures and so on. Okay, so okay, the normal case is we're going to optimize for that. So status success is the most common one. There are some specific ones that are defined as the protocol that correlate to common actions. So persistent reservations, because we do expect or we optimize for a failover clustering workload in the guest. Things like validate happen, cluster membership happens. That all happens through persistent reservations. So the specific unit attention codes there are translated into NT status codes. Okay? So for example, if there's unit attention available, we return that. Okay? If the capacity data of the underlying device has changed, we return that. If there's a reservation preempt or release or anything like that, we return that specific status code back, and there's no round trip. Okay? Send the SCSI read or write, get the special status code back, you're good to go. Then there's everything else. There's all the other error codes. I don't even want to pretend to try to know what they all are. I'm not a SCSI expert as much as some people in this room are, that's for sure. So we store them in the server, and there's another one of those tunneled operations that you say, hey, go retrieve me the error returned from this operation. Okay. So backing up, read or write, we return a status code that includes a key, and you go back, and you issue another file system control, and you get all your sense data back. Okay. So what does that look like? So the server, we tunnel some more. On a file read or file write, the server stores the information, and it's per handle. There's 256 slots. It's up to the server how they want to manage those slots. Okay. The server returns a key back, and the key is the last byte of the status code. Okay. So this whole NT status code range right here is reserved for these keys. Okay. All right, so we tunneled some more. Okay. Quick note on versioning before we go on. The client, it identifies its version through the device context. Okay, and it's up to the client to query the server for its version. And it returns it in the, I think we call it get starting info, maybe get basic file information in the protocol. The name changed. And that returns the server version. It's up that point to the client to send things the server will understand and for the server to respond in ways the client will understand. It's not an in-depth negotiation where we agree on a certain protocol version to speak at. The assumption is that clients will get better over time and know how to talk to servers, and the servers will always maintain backwards compatibility with the clients. Quick note of that. All right. Okay, before I move on to some use cases and troubleshooting and all that type of stuff, any questions about this? No? Brilliant. Okay. All right. Go for it.
So just looking at MSRSVD, so it seems like one of the critical things is that create context you're talking about.
Okay.
And I was just wondering what the exact name is. This is SVHDX.
Yeah, it's open device context, I think is the name.
Okay, so this is the thing with the originator ID, the originator flags, and request ID, right?
Correct.
And
So he's asking the name of the device context in the protocol document itself.
I guess what's a little bit scary is it has a whole bunch of flags, and they're all listed as reserved, except for like one very obscure thing. So there's one flag that's defined, right? It's originator versus the originator is a parser versus the originator of the object store.
Yep. All right. Let's talk about that. Okay. I thought this might come up. So the originator comes from, it's a way, the open device context is generally used by this protocol, but it's also used by some other components inside the file stack to figure out ways to deal with it. Okay? So the one that we originally documented was 1. And this is, so we're looking at the open device context, and in that there's originator flags is the name of the field. Okay, and there are some values in there. The field is 1. Everything's cool. It's what we just talked about. Okay, everything we just talked about is there. Okay. If it's 16, it's a test or debugging flag, but treat it all the same. It's the same. It's just an option to say, hey, this is coming from a test client as opposed to a real client. That's not in the spec. There, I believe. Yes, I believe we are currently working on clarifying that in the spec itself. This is definitely something there. Okay. And if it's 2, this is one of those. It's going to be reserved. It's a recursive open. Okay. It's not on the wire. However, if you're a file system filter, you got to know that this is there. Okay. Essentially, it means that the file server component on the Windows server that implements this is doing an open on that stack. So components in the stack know how to deal with it. There are some recursive issues there. But from your perspective, if it comes to you as 2 across a wire, then treat it just as a block device. Now, there are some cases when you don't treat it as a block device. And this is why I said for the most case, if it has the alternate data stream, it's a block device. It's except for these 2 cases here. If that originator flags is 4, then the create file request is coming from the component that parses files. In Windows, this is called VHDMP. Okay, and that's why you might see the name VHDMP. Okay. This is the component in Windows that supports taking the file and turning it into a disk. It translates all the SCSI commands and all that, does all that type of stuff. When I say parser, this is what I'm talking about. We need to know this because a client might be misconfigured. So if a client is misconfigured and says, hey, I've attached the virtual disk to this virtual machine, but I didn't say share it, it's going to try to open it up as a normal file. Okay? And it'll get status sharing violation. and then we'll show the user status sharing violation, and the user goes, great, what do I do now? Okay? So to avoid that, there's another status code, status VHD shared, that's got a nice error text that says, hey, the file is already opened in shared mode. You have to open this disk as shared mode. Make sure your configuration is right. And so if the block device has 4, and a create file request to the underlying object store would result in a sharing violation, the server needs to report status VHD shared instead. Okay? Then the client knows, hey, okay, this is a shared disk. Either show the better message back to the user or try to open it using the RSVD protocol and do what I needed to do anyways. Okay? I have no idea. The question was if the MP in VHDMP is for Miniport. I don't know. That's something we can definitely ask Patrick after this. He might know. All right. And then 8. It's another type of recursive open. In this case, on the file server stack, it would happen if the parser on the file server opened the request on the file server itself. Again, so if you're writing a file system mini filter, you need to know that, but it's not going to go across the wire. However, it does affect server behavior, so don't treat it as an open. But it's not realistic to see this. It's an error condition. It's not expected. So these are all the possible flags. Everything out of these flags is out of bounds.
Yeah, so just to clarify on their statement, VHDMP is the VHD Miniport driver.
Okay.
Like if you look at the command that's installed with Hyper-V, you can also mount and dismount VHD files using it for local access.
Yeah, absolutely. So to answer, the question here, but does this answer your question about these, or?
Yeah, and I guess the only other thing that, oddly enough, I think that the only other kind of odd thing about this, right, is that the version info is also sent in the context, right?
Yes.
And right now there's only a version 1.
Correct.
Right? And that was added in Windows
Server 2012 R2.
And 8.1 as well, or just the server?
8.1 as well, actually. Yeah.
So the other sort of related question, and maybe I missed this earlier, but I can sort of imagine Hyper-V ending up calling this on an 2012 R2 server, but in what case would we see a Windows 8.1 mount? Because presumably it's going to send your various version info and other things as text as well in these fields, but it'll have the numeric version 1. But when would Windows 8.1 actually send an RSVD open?
So we have a great policy of Hyper-V. If we support it on the server, in general, we support it on the client as well. Okay. And so because we support it on the server, all the same scenarios apply on the client. Okay. So again, it's not a mainline scenario. I definitely wouldn't expect to see this in enterprise deployments. It doesn't make a lot of sense, but it's there. So you could see a Windows 8.1 client emit this if it's configured to have a shared virtual disk.
And we're not expecting to see a version, like none of what you're talking about in the talk is a version 2 of this. This is all version 1 still.
Yeah, this is all version 1. We're not. The question is, are we expecting to see a version 2? And the answer is, likely in the future there will be changes to the protocol, and if they are, then the versions would probably increase. So, such as it is. Okay, does this answer your question about the device context flags? Awesome. Okay. Any other questions about the protocol? Okay. All right. So you've decided to do it. All this looks reasonable. You bought into the value prop. You've bought into how to do the protocol. Some basic in-box tests that you might have, that we ship, that you might use. Let me talk about some of those and some of the diagnosing and some of the troubleshooting stuff. Again, this isn't like a protocol test suite or anything like that. This is stuff that comes in the box that you'll be able to use. So one of them is failover cluster validation. So in your guest, it's got shared disks. Okay. You can run validate cluster. You can do it through the UI or through PowerShell. And this does a bunch of persistent reservation tests, failover tests, all those things. It's comes back from the Windows Server 2008 days, and it's been constantly updated throughout. And it's just to make sure that the underlying storage matches the requirements that failover clustering needs. And the support statement is that if your cluster passes validate, then it's supported. Okay, so if the storage passes validate, pretty good to go. Okay. Now, we all know that maybe because we're virtualizing the whole stack, on the server, you could probably pass validate without actually doing it, but then that would be bad. So it has some output. It's got a nice, pretty HTML report that says, hey, here's all the tests we ran, and here's all the things that failed or the things that passed. And it's also got a validate storage log file. Okay. The MHT, the HTML report, is very customer focused. It's very CSS focused. They talk about, it lists all of your cluster disks and all of your networks and all of your applications and all your environment variables. It's like a best practice analyzer or report, inventory report of that. But it's there. And the validate storage log is a more in-depth version about what is actually going across the wire. Now, it's still not actual, issued SCSI command 5E with, key 5, service action 4. But it does give you some more hints, like the actual keys that are used and all that type of thing. Okay. So part of validate, and this is a snippet from the HTML file, are the storage tests, and there's a bunch of things here. It'll list your disks, which is really useful, and I'll talk about that in a minute. And it'll go through all of the things, and it does VPD information, persistent reservation information. It does simultaneous failover. It's really cool. I was really happy when I finally got this to pass when I was writing this. I was super excited. One of the useful things is you can list disks, and you can use that to correlate disks. So on your host, you can get the controller number, location, and path of the virtual hard disk file. Okay, so in this case, on that VM, we've got controller number 0, location 1, and its path is this. And they're all SCSI controllers, so that's just assumed here. Inside the guest, that shows up. And it shows up in your validation report. Okay. Now, validation reports, if you run this and it fails, it'll tell you which disk it used, and it'll use one of the GUIDs or the signatures and so on. But it won't give you the port information, and so you won't be able to get the file information, which is kind of frustrating. So here's how you correlate those, which is kind of nice. And if you want to, you can look at our validate storage log. Here's a little bit of an example. It's per node, and it includes some details of the PR commands. In this case, here we tried to PR arbitrate using a PR key. Okay, we offlined a disk with a signature, and we did some other arbitration steps there. Just as an example, if you run validate, you can open up this file. It's a big dump. You can see what's there and play with that. Okay. Here are some resources. We've got the protocol specification online. There are some TechEd and TechNet talks and information that have some demos and that describe how you can set this up in more detail. And then obviously a good reference to SCSI, SPC3, SPC2, but it's a SCSI transport.
I see some references to the TechNet described this cluster, and it's pretty interesting. But it's not on my Windows 8.1 enterprise, so I'm wondering what component it comes with.
It comes with the failover clustering component. So the question is, how do you get test cluster? And the answer is you install Windows Server in a guest, and you install the failover clustering component.
It says it also applies to Windows 8.1, but I don't know how you get on 8.1 either way.
Okay, so the question there is, it says it also applies to Windows 8.1, and I think the answer there is that it comes through the remote RSAT tools, remote something, 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 something. Essentially, you can use your Windows 8.1 client to manage a Windows server. So you still need the Windows server, so I don't know how many virtual machines you want. But. There's Jose correcting me. It's the Remote Server Administration Toolkit is the name of what that comes from. Okay. Yeah, test clusters are great. Our validation is great. It runs through all the stuff. It's a great multi-machine SCSI or multi-initiator SCSI compliance test around the persistent reservations and so on. It's kind of what we use, or it is what we use to to validate our SCSI implementation in that case. Okay, any other questions? The question is the VHDX a standard formatted VHDX? And my question, by standard, do you mean? So the question is about the disk layout that's published as part of it is, actually. It doesn't have to be, but it can be. The protocol, I could construct a case where you would virtualize everything or maybe have a LUN or something like that on your storage device that would all represent to this. But in the Windows Server world, it's just a file. Okay. But the key to the scenario, though, is still being able to manage it as a file. So if you abstract that out completely and you don't have this easy file management, then I think then you lose some of the charm of this whole scenario. Any other questions? Awesome. Thank you guys very much for your time. I really appreciate it. That's all I have.